Rajeshwari MJ. She pursued her BE in Electrical and Electronics at the People's Education Society College of Engineering, Mandya. She pursued her MTech in VLSI Design and Embedded Systems at the Sri Jagadguru Balagangadharanta Institute of Technology, Bangalore. Her personal skills lie in good verbal and written communication skills. Her areas of interest lie in OOPS with C++, renewable energy sources, HVDC transmission, digital relays, automotive electronics, advances in VLSI design. She has also had papers presented at the national level, such as the Innovative Architecture for SoC Multi-Core Hybrid Processor, presented at the RNSIT, Bangalore.
Welcome to UGC lecture series of BSc Applied Electronics. Today we are dealing with the subject Semiconductor Devices and Integrated Circuits, Unit 2, the Junction Transistor of Lecture 2, Semester 4. The topics that we are going to discuss today are SCR, that is Silicon Controlled Rectifier, and a Shockley Diode. Let's start with the Silicon Controlled Rectifier. Till now we know about the diode and the transistor. We know the feature of diode and its application, and also the transistor feature characteristics and its application. We can use diode as a rectifier and transistor as switch as well as amplifier in analog circuit, switch as a digital circuit. So, if we combine both the transistor and diode feature, we will come up with another new device, new semiconductor device, which is called as Silicon Controlled Rectifier. Why it is called as Silicon Controlled Rectifier? Why it is silicon? Silicon because compared to germanium semiconductor, in silicon the leakage current is less and controlled, means the rectification here can be controlled through a gate input. That is why we call as Silicon Controlled Rectifier, and it has both the property of diode and transistor, diode property of rectification and transistor property of switch. And this SCR is also called as thyristor because let us see the symbol and we compare this as a why we call it as a thyristor. From the symbol of SCR we can observe that it is made up of 4 layer PN, 4 layer and it has 3 terminals. The 3 terminals is called as anode, gate, cathode, and we can observe, as I said, it is made up of diode and a transistor. From the symbol we can observe that PN can make the diode, PN junction diode, and NPN can make a transistor. So, the total we called as a silicon controlled rectifier. The P type material of a diode is anode and the base NPN transistor base is called as a gate terminal. The N type material is called as cathode. This is how the terminals are named in a SCR. And SCR is also called as thyristor because it is a device where we can completely switched on or completely switched off, and here the rectification is controlled by a gate input. And also one more thing, in a thyristor the grid, plate and cathode is compared to anode, the gate and cathode, anode, the gate and cathode of a SCR. The grid, plate and cathode of thyristor is compared to anode, gate and cathode of SCR. This is why we called as a SCR also as a thyristor. Next we move on to how this SCR will works. The working of an SCR, we will consider 2 conditions. When we are going to apply the gate voltage, what will going to happen? If we not apply the gate voltage, what will going to happen? How the SCR will works? Let us look into the circuit. This is the circuit which is having 3 junction, 4 layer, 3 terminals. Okay, J1, J2 and J3 are the 3 terminals, 3 junctions, and 3 terminals are, this one is anode, this one is a cathode and this one is a gate. So, here the very first condition we considered is when a gate is open, when there is no voltage across a gate, this gate input, what happens for an SCR? And here we need to note on that for anode terminal the load resistance is connected series, and this is the voltage V is a supply voltage. If no voltage is applied, for the junction J1 and J3 becomes forward bias and the junction J2 is reverse bias. It is like J1 and J3 acts as a NPN transistor with a base open if we won't apply a gate. And what happens if we apply the voltage as we increase the supply voltage, that is the V is increased. Before it was gradually we are giving the voltage, as we go on increasing the voltage, the J2 will breaks down due to the voltage that we are giving will be equal to the reverse voltage of a junction J2. So, the junction J2 will going to be break down. So, there will be a possibility of conduction. Now, we call the SCR is conducting heavily and it is in on state, and also the applied voltage at which SCR conducts heavily, that voltage is called as breakover voltage. Above this voltage or equal to this voltage, the SCR will conduct heavily. And when we are not going to apply the gate, that is we need to know when we not going to give the gate voltage, the voltage at which SCR will going to conduct heavily, that voltage is called as breakover voltage. Next we move to another condition, when the gate is positive with respect to cathode. The first condition what we considered is when we are not going to give a gate voltage and when gate is open. That is the first condition. Next condition, when gate is positive with respect to cathode, what happens? We are connected the positive voltage, the gate is made positive, the positive terminal is connected for the gate and the negative terminal for the cathode, and remaining things are same. RL is connected across a anode, V is a supply voltage. Junction J3 becomes forward bias when we apply a positive voltage across gate. The electrons from the N type region will move to the P type region and the holes from the P type region will move to right side to the N type region. So, the electrons crosses the J3 terminal and it attracts towards the N type material. So, it crosses the J2 terminal also, consequently the current in the anode increases. So, when the current in the anode increases, there will be a chances of more number of electrons in the J2 junction. This is a J2 junction. So, there will be more number of J2 electrons in the J2 junction, which will make the J2 to break down. So, this breakdown will make the conduction of electron and hence the current flows, and we can say that the SCR is turned on. So, the SCR in the on state. This is how when a gate is made positive with respect to cathode, the SCR will going to work. We can also know about the working of an SCR by another equivalent circuit, that is by transistor equivalent circuit. Let us see how with the transistor equivalent circuit the SCR will going to work. As I said, it consists of 4 layers, that is PN 4 layer. Can we make this PN 4 layer into 2 transistors, and as we can make it, let us see how the circuit will looks. If we break this 4 layer, it will become like this: PNP and NPN, 2 transistor, one is of PNP type, another one is NPN type. The emitter is same of a T1, this is called as T1 transistor, this is T2. Here one thing we need to observe is the base of a one transistor is connected to collector of the another transistor. Similar thing, the basis of one transistor is connected to the collector of the another transistor. This is how we can make a circuit of a transistor equivalent SCR. So, when the gate is open, the very first condition, when the gate is open, there is no current in the base. So, the transistor T2 is off, so that the transistor T1 is also off, in off condition. That is when we are going to voltage across a gate, this S switch is closed, the IB, the base current will flow, and the due to the base current flow in the T2 in the transistor 2, the collector current of a transistor 2 will increase. Since we know that the collector of T2 is a base of T1. So, hence the base current of a transistor exists here in the T1, this will increase the collector current of T1. So, this makes the transistor T1 and T2 in a operates in the saturation mode and makes a transistor 2 in a saturation mode and makes the SCR turn on. This is how we can explain the working of an SCR with respect to the transistor circuit. Next, some of the important terms we need to know about SCR, which are the breakover voltage. What do you mean by breakover? It is a maximum voltage at which the diode will, the SCR will going to conduct heavily when gate is open. This is the maximum voltage. Both this SCR will going to conduct heavily, and below this it won't conduct. And one condition we need to know is the gate, when the gate is open. Example, if a breakover voltage is 200 volts, means the SCR won't conduct below the 200 volts, and when it reaches 200 volts it starts conducting heavily. Another one is peak reverse voltage. This peak reverse voltage is plays a very important role, since the SCR is going to use an AC circuit. So, there will be positive and negative cycle. The negative cycle, we should not have a peak inverse voltage greater than the reverse voltage. If it is the peak inverse voltage is greater than the reverse voltage of an SCR, then in the negative cycle also the SCR will going to break down and it conducts. So, this will leads to damage the SCR. That is why always we need to note down the peak reverse voltage should be less than the reverse voltage of SCR. What it is? It is a maximum reverse voltage that can be applied to an SCR without conducting in the reverse direction. That is what? That is a maximum voltage at which the SCR won't conduct when we are going to apply the reverse voltage, and commercially available SCR will be having 2.5 kilovolt of peak reverse voltage. And next is holding current. It is a maximum anode current gate being open at which SCR is turned off from on condition. This is very important, we need to note down when we need to turn off the SCR, the holding current plays an important role. We need to know what is the holding current. If we know the holding current, by varying the voltage of the gate terminal, we can reduce the current less than the holding current, so that we can make a SCR turn off. The only way to turn off the SCR is to reduce the supply voltage, because once the SCR is start conducting, even though if we remove the gate voltage, and the gate will going to completely loses the control over the SCR. Even if we remove the gate voltage also, the SCR will going to conduct heavily. So, it is a maximum anode current gate being open at which SCR is turned off from on conditions, and it is about 5 milliamps. And forward current rating, forward current rating, it is a maximum anode current that an SCR is capable of passing without destruction, means I can say it is a safe current, safe range of current till the SCR will conduct without damage. This is called as forward current, and it could be 30 amperes to 100 amperes. Next we move on to VI characteristic. We know about some of the terms of SCR. Now we let's know about the VI characteristics of SCR, and it is a curve between anode to cathode voltage across anode current. Let us see how it works with the variation of anode to cathode voltage to anode current. When we are going to give us this region, the first quadrant we considered is a forward characteristics. In forward characteristics, when Ig, when we are not going to give a gate voltage, what will going to happen? Initially there will be very less voltage. Okay, initially there will be very less voltage due to the leakage. When we are going to increase the voltage, there will be a point called breakover voltage, that is the maximum voltage at which SCR will going to conduct heavily. After this there will be a dot or title. Why it is? Because the SCR, once it reaches the breakover voltage, will suddenly drops the voltage, it will come back, but the current will go on increasing here. This voltage will appear across the load resistance. That is why we have mentioned this is a dotted line. As we decrease the voltage here, the current will go on increasing even though the voltage is decreased. This is the characteristics, this is the forward characteristics of SCR. When anode is made positive with respect to cathode and the gate current is 0. And next is reverse characteristics. In reverse characteristics, the anode is made negative with respect to cathode. It is similar way, during when we are going to apply the voltage, there will be very small current due to the leakage current. There will be the current will be very small amount. As when it reaches a certain voltage, there will be a breakdown. When the voltage equal to reverse voltage of an SCR, reverse breakdown voltage of an SCR, the junction J2 will break down, so that avalanche breakdown occurs. It appears like this. This is a VI characteristics of a SCR. Let us take a short break. Welcome back. Now we are going to learn about SCR half wave rectifier, one of the application most commonly used SCR as a rectifier. How SCR will going to work as a rectifier? As I said, it is having a property of diode and transistor, and it is a silicon controlled rectifier. Let us see how it is going to control the rectification. The supply that we are going to rectify, the AC supply, is fed across primary of the transistor, and it is taken from the secondary of the transistor, is fed to the load. This is the load that where the secondary voltage will going to conduct, and this load is connected in series with the SCR, and the SCR will having a R is the variable resistance in the gate circuit. This is a gate circuit, and this is a voltage that we are going to give to the gate input. When we are going to increase the gate current, when we are going to give the gate voltage, by varying the resistance, we can control the gate voltage at some voltage, like such that if you make a voltage of gate current of V1, then the SCR will start conduct at point V1, which is less than the Vm. Vm is a peak voltage of a supply, V1 is a lesser than the Vm. It starts conducting from V1 till it reaches to 0, and the point at which the SCR start conducts, the angle, it is called as firing angle. The angle at which the SCR start conducting is called firing angle, and we can, from the firing angle we can find the conduction angle. This is the 180 degree. The only conduction part is the shaded part here. After firing angle only we can conduct the SCR. So, the conduction angle will be 180 degree minus alpha, remaining this part, this is the conduction part. So, the conduction angle of an SCR half wave XCR is 180 degree minus alpha. This is how the SCR half wave rectifier works, and in a negative cycle it won't work because the peak reverse voltage is less than the reverse breakdown voltage of a SCR. That is why it will going to work only in the positive cycle, that too with the controlled gate voltage. SCR full wave rectifier. In the SCR full wave rectifier, the secondary winding will be tapped, and this tapping is connected with to the resistive load. And here we can observe there are two SCR, one is SCR1 and another is SCR2, and for both of it there will be gate circuit with the variable resistor R. Here also the same way, when in the during the positive half cycle of the secondary voltage, the SCR1 will going to turn on due to the gate input voltage makes to a value of V1. When we are going to make the gate input voltage to a value of V1, the SCR1 will going to on in only during the positive half cycle of secondary voltage, and in the negative half cycle this will become positive, and SCR2 will going to conduct. So, AC supply for both positive and negative cycle will be rectified in a full wave rectifier. That is why it is called as full wave rectifier. Both positive and negative cycle will be rectified, and same thing that V1 will be the voltage which is less than the Vm, and the conduction angle will be 180 degree minus of firing angle, that is alpha. And one thing we need to observe from a SCR is we are going to have a rectification, that too with the control. How much amount of voltage should be passed can be controlled by the gate voltage. Then application of SCR. SCR as a static contactor we can use. Why it is static means there is no any moving part, that is why it can be used as static contactor. SCR can be used for power control, SCR for speed control of DC shunt motor, and also SCR for crowbar circuit. A crowbar circuit will helps to maintain the voltage sensitive load from a variable DC supply. It has a crowbar circuit. Next we move on to a very important and a very special type of diode is Shockley diode. The name Shockley comes from the inventor Shockley, William Shockley, that is why it is called a Shockley diode, and this diode will have a 4 layer and it is named as P1, N1, P2, N2, and it is having a 2 terminal anode and cathode. We can observe here the layer are 4. The only difference from Shockley diode and the SCR is there is no one more terminal. There is here it is only 2 terminal anode and cathode. In the SCR there will be another terminal called gate terminal will be there, and we can also mention the Shockley diode as a 3 diode. So, one is D1 that is making a direction downward, D2, D3, like this we can make a, this is the diode analogy of the Shockley diode, and the symbol of Shockley diode is represented like this, anode, cathode, this is only having a half arrow mark. Then how the Shockley diode will going to work? This is also works somewhat similar to SCR. There are some difference in the reverse voltage, that is what we are going to observe is there is no gate input. That is one of the important difference between Shockley diode and the SCR. When the Shockley diode is forward biased, diode D1 and the D3 is forward means anode is positive, cathode is negative. So, diode D3 and D1 is obviously in forward and D2 would be in reverse bias. Since this is in reverse bias, when we are going to increase the voltage, when the voltage reaches the VBO, that is breakover voltage, this D2 will break down and it will going to conduct the diode, the voltage across this, the reduced voltage will appear across the load. Then even though voltage is decreasing, the current will be increasing as in case of SCR. And what happens in the reverse bias condition? When Shockley diode is reverse biased, the anode is connected negative to the negative terminal, cathode is for positive. Diode D1 and D3 will be reverse biased and D2 would be forward bias, and this condition is never operated because when the D2 is breakdown due to application of reverse voltage greater than the reverse breakdown voltage, the Shockley diode made damage, that is why it is never operated in the reverse bias condition. And some of the conclusion that we need to make from the Shockley diode are, what are the observation that we made are, it is Shockley diode can be used as a switch. So long as the forward voltage is less than the breakover voltage, Shockley diode offers very high resistance, because when it is very we are giving the voltage less than the breakover voltage, the Shockley diode not turn on. So, we can say it is having high resistance and practically conducts no current. This is one of the important thing, it does not current and it having no current, it is having 0 current. At voltages above the breakover value, the Shockley diode presents very low resistance. So, when the voltage increases and it reaches above the breakover voltage, the Shockley diode will have the less voltage, less low resistance, and we can say the Shockley diode will conduct heavily. And we may be noted that the Shockley diode is also known as PNPN diode or 4 layer diode or reverse blocking diode thyristor. These are the different names we can call as a Shockley diode. And one more thing, when the Shockley diode is turned on, the only way to turn it off is to reduce the supply voltage such a value so that the current flowing through the Shockley diode will be reduced. This is the only way to turn off the Shockley diode. And diode D2 then becomes out of its reverse breakdown states and again it reaches its high resistance, so that when we are going to reduce the value of applied voltage, we can make the D2 in the reverse bias condition and again it reaches a high resistance. So, it comes back to original, that is from the turn on condition it comes back to turn off condition. This is the only way to switch off the Shockley diode. The application of Shockley diode, it can be used as a relaxation oscillator and also as a trigger switch. This Shockley can be used as a trigger switch for the SCR. Many cases we can use it as a trigger switch of an SCR, since we observed that in the forward characteristics of the SCR and the forward characteristics of Shockley diode are same. So, this Shockley diode can be used as a trigger switch. Summary: what we learned till now is about the SCR, its VI characteristics, breakover voltage, the holding current. What do you mean by holding current? Peak reverse voltage. What do you mean by rectification? Types of rectification in SCR, the firing angle, all these things we come across with the SCR. And when it comes to Shockley diode, again we learn about VI characteristics and how it is different from SCR, and also how we are going to turn off the Shockley diode and its application. Some of the questions of this session are: how does SCR differ from an ordinary rectifier? Why is SCR always turned on by gate current? How does Shockley diode works? References: www.talkingelectronics.com, www.electronics-tutorial. You can refer the textbook Electronic Devices and Circuits of G.K. Mittal. This ends up the session. Thank you.